Hi, in this video we'll be discussing the importance of iodine in the gram staining process. Let's get started. Let's start by discussing the gram staining process for gram-positive bacteria. Here we have our gram-positive bacteria represented by this oval shape. And as you can see, we've zoomed in to the cell wall of the gram-positive bacteria. The first step in the gram staining process is to apply the crystal violet. The crystal violet dye molecules are positively charged, or they're cations, and the cytoplasm of the bacteria is negatively charged. So attracted to the negatively charged interior, the crystal violet dye molecules will make their way down into the cytoplasm. The next step is to add the iodine, which acts as a mordant, and this just means that it intensifies the stain. And very soon you know what I mean by intensifying the stain. The iodine molecules travel to the cytoplasm. The two combine to form a crystal violet iodine complex, or CV1. The next step is the application of alcohol. Alcohol dehydrates the layer of peptidoglycan, which shrinks the layer of peptidoglycan in the pores, making it hard for the crystal violet iodine complex to escape the cell. Due to the large size of the crystal violet iodine complex, it remains trapped in the cytoplasm of the bacteria. So even after applying the saffron dye, the bacterial cell remains stained purple. The purple of the crystal violet dye is a much more overpowering color than the lighter saffron dye. And the reason that the saffron dye molecules are able to reach the cytoplasm is that because just like the crystal violet dye molecules, the saffron dye molecules are cations, or are positively charged, and they are attracted to the negatively charged interior of the cell. So that, along with the fact that it's small in size, they can move through and enter the cytoplasm. By the end of this process, the gram-positive bacterial cell would have stained purple, because recall that the crystal violet iodine complex are quite big and remain trapped in the cell. So even after the application of the saffron dye, the color remains purple because the purple is a more overpowering color than the lighter saffron dye color. Now let's move on to discuss what happens for the gram-negative bacteria. When gram staining for gram-negative bacteria, the first two steps happen exactly as it did for the gram-positive bacteria. And so after applying the crystal violet and the iodine, we end up with the formation of the crystal violet iodine complex inside of the cell. In the decolorization step, alcohol dissolves the outer membrane and dehydrates the layer of peptidoglycan. However, in this case, the pores are large enough for the crystal violet iodine complex to escape or to be rinsed out of the cell. So then when we apply the saffron dye, the gram-negative bacteria takes up the color of the saffron dye, which is red or pink. So at the end, the gram-negative bacteria is stained red or pink. That is it for this video. I hope it helps. Please like, subscribe, comment, and share.